hi everyone. Firstly, I want to say thanks very much to Anatoly and also Philip for the opportunity to come and present at the Social Media Lab. I've been admiring the Social Media Lab from afar, and I really do mean that, from afar. As you know, I'm from Canberra, so in Australia, so I'm on the other side of the globe, and so it's a great opportunity. This is my first time in Toronto to meet with the team in Toronto and find out more about what's going on, and it's a great opportunity to come and give a presentation to the class as well. So Anatoly's given a really good introduction to me, but I'm just going to, so I can actually skip through some slides, introductory material. So as Anatoly mentioned, there's the Boson Lab has, we've got these different dimensions to it. There's research, there's software tools, and then there's also teaching and training. So I want to focus on the tools. This is just some introductory material before I start talking about bots. So these are the people that I work with. So this is a network of the contributions, showing the contributions to the different tools that the Boson Lab have put out. So the first one was the Boson software for hyperlink network research, which Anatoly mentioned. And then more recently, well, as the world moved into social media, online behaviour started to take place in social media, of course we had to adapt our tools and research focus, and that's led to these other two new tools, Boson SML. We used to call it Social Media Lab, but that was obviously just a source of confusion because there was already another Social Media Lab here, for example, and so we renamed it Boson SML, so that's an R package for collecting network and text data from social media. And so it currently works with, actually I've got some additional slides on Boson SML. And then Boson Dashboard is the user interface, or a user interface for working with collecting and analysing social media network and text data. So the Boson SML package is, these are the developers. It was created by my colleague Tim Graham. He was the lead developer, but more recently Brian Goertzel has taken up the mantle and is doing a lot of work in terms of extending and improving the software. But as I mentioned, it's an R package, and we've designed it to be like a Swiss Army knife for collecting network and text data from social media. So it allows a fairly simple. It means that you don't have to work directly with the APIs. You can do that through the social media package. And there's a call that you will make. This is an example call where we were collecting tweets featuring a particular hashtag, ICA17. And this is all the code that you need to get a network object. This is an graph object. That's what's down here. And then you're in the world of iGraph. You can do all the network analysis using iGraph within R, or else you can export it as a GraphML file and do nice visualizations in Gephi, such as that one there. What I found was that, so Boson SML has been a really great tool for teaching. That's one of the primary motivations that led to the creation of it, was because I started to teach master's courses where I was wanting my students to learn some R and to do some data collection and analysis. However, from 2018, I started teaching undergraduate students, and these are students who are coming from various parts of the university. They could be in the Bachelor of Applied Data Analytics at the ANU, so those are people who are doing coding, but also some of my students are sociology majors, and they may not have even done a stats course. But they want to collect and analyse social media data. So that led to the creation of Boson Dashboard, which is a user interface. So this is a shiny, an R shiny web app that sits on top of, or that makes use of Boson SML to collect the data, but then an iGraph is basically sitting underneath there, doing for the network analysis and visualisation. I am actually giving a presentation tomorrow at the Catalyst at the FCAD. I don't know, it's a Faculty of Communication something, Arts and Design, I think. And so I'm actually going to be giving a bit more of a demo of Boson Dashboard tomorrow. So Oh, and then Anatoly very kindly mentioned my book, Web Social Science, that came out in 2013. I still cringe a bit when I see the cover of this. I think they could have done a lot better on the network. But anyway, as we all know, you can't judge a book by its cover, but it still makes me cringe a bit. But anyway, so this is a book that's out there, and again, I created it in the context, or wrote it in the context of my teaching. Let's move on to the research dimension of the presentation. So we all know, I think, that in the last couple of years there's been a lot of interest in bots. I was talking with Philip and Anatoly earlier on today about researchers such as Social Media Lab knew about the concerns associated with bots, and we're doing work in this area as far back as 2011. But it was really the 2016 US presidential election, and also, I guess, the Brexit debate and vote in the UK has led to concerns about the political behaviour and the potential political outcomes associated with bots. And so really it became a huge kind of issue in 2017 in the sort of the wake of the 2016 US presidential election. And as a result, and I don't want to come across as what you might call an ambulance chaser, but when controversial things are occurring regarding the web, researchers tend to get interested in this because we all want to be doing work in an area that has impact and where we can be making a contribution to the debate and to the understanding of the web and how it's affecting politics, for example. And so with a lot of other colleagues around the world, I got interested and started doing work on bots in 2017 and 2018, and so I'm going to talk a bit about that research today. So the two research projects that I'm going to outline are, first one is understanding the influence of bots, and so we know that bots were present on Twitter during the US presidential election, but the question that's being asked here is, well, what were they doing and were they influential? The second question is more, I would say, is more of a social science or a sociological question, which is, what were they doing? Were they present in conversations on Twitter? And if so, what role were they taking, and how does that differ from the role that humans were taking in those conversations? So we're really talking about two different aspects of Twitter behaviour in these two questions. This one is about information diffusion, and really I think Twitter is, its main purpose is as a tool for diffusing, promoting and pushing out information. But there are also conversations that take place on Twitter. People do use it for, interacting on a one-on-one basis and exchanging ideas, and so that's what we're looking at here. So I mentioned that I got interested in social bots in the context of the US presidential election. That's when I started doing empirical research into bots. I actually had my interest and my involvement in bot research did predate the US presidential election, because I contributed to a book chapter with my colleague Tim Graham at the ANU, and this book came out early 2017, but we actually had written the chapter well before the US election. But this was a thought piece, really. This was you can see the title, Do Social Bots Dream of Popping the Filter Bubble? And so this was looking at the potential of bots for bringing about socially desirable outcomes or politically desirable outcomes via their behaviour within online networks. And of course, whether it's socially desirable, it all depends on the eye of the beholder. But in this context, we were talking about the role of bots as their ability to maybe break up conversations or networks that were considered to be homophilous, in the sense that it's all like-minded actors talking about the same thing, confirming kind of previously held beliefs. And so that's represented here by this. This is not empirical data, by the way. This is just a visual, something that we just drew. But you've got here a a popper bot being planted in the middle of a conversation where we have the red and the blue dots indicate whether they are conservative or liberally, or in terms of their partisanship. And so this is a bot that's designed to break up a homophilious network. This is another bot that's designed to connect to homophilious networks, so to bridge, and this is called a bridger bot. So this was a sort of it was quite a fun paper to write because we didn't have any data and we didn't have to prove any hypotheses. So we just sort of let our imaginations fly. So that was the start of my interest in bots, but then it was the 2016 US presidential election where I started doing empirical work in this area. So the first paper to talk about is the influence of bots. So this has been published at the ICWSM conference earlier last year, so the International Conference on Web and Social Media. So this was a paper that was joint with some computer science colleagues at the ANU, as well as Tim Graham, who is at the School of Sociology. Well, actually now he's just moved to the Queensland University of Technology. So the data. So one of the advantages that we had in terms of contributing to this global research agenda into the US election was that we had a data set that was quite novel, and this data set was collected via, I have a company that I created to start to commercialise software that I was creating at the ANU. The company's called Uberlink, and so we collected a data set, and you can see what it is. It's the data set that covered the first televised debate. And so on 26th of September 2016, what we did was we collected all the Twitter activities, so these are tweets and retweets, containing at least one of these following hashtags. So we did some preliminary analysis that suggested that these would be important hashtags, and so these are the filters that we use to collect our Twitter data. We collected over a 2-hour period, so it's the debate plus the 15 minutes before and after the debate, and we collected around 6 million activities, so those are tweets and retweets, reported by approximately 1.4 million users. Now the dataset is further described in the paper by Rizzo et al., but it's also described in a paper that's just been accepted for publication with Craig Robertson, Bill Dutton and Winston Peng at Michigan State University. And in fact, it was actually in the context of this research that this led to me collecting the data set. So I collected the data set not for bot research, and I guess this is an example of where opportunities arise and you have some data and then you think, okay, well, this is a new angle that I can use or I can examine with the data set that I have. So it was actually collected in the context of this research, which is looking at this phenomenon of twin screening, so people who are watching the debate and then they're on Twitter. So this is more of a political science paper, or political communication paper that didn't have any bot dimension to it. So in this research, we had 3 methodological challenges. Firstly, we had to identify the bots. Secondly, as become apparent, we also needed to classify Twitter users based on their ideology, their political ideology or partisanship. In particular, we wanted to be able to do analysis with networks looking something like this, where we have Twitter actors and their political orientation are either conservative or liberal, being coded up, being available as an attribute for the actors in the network. Finally, we had to come up with an approach for measuring influence. And here we're defining influence as contribution to retweet cascades. So it's what impact did me as a Twitter user have in the diffusion of information via retweets during this debate, for example. Now, I'll talk later on about whether or not this is a real measure of influence, or whether it's, what is, the limitations associated with this as an indication of influence. But these are our 3 major methodological challenges. And the thing is that we had to be able to do this at scale. So this is a big data issue or situation, because we have 6 million tweets and retweets and we have 1.4 million users. And As a social scientist, I'm more than happy with taking samples and doing an in-depth analysis with samples, but I wouldn't have been able to get the computer science colleagues interested in such a project. So we wanted to do something, they're interested in scalable research methods, and I have an interest in that as well. But so we decided, this had to be an approach where all of these three things could be scaled. So firstly, bot detection, how did we do that? Well, we used an off-the-shelf service, bot or not. It's since been renamed. This comes out of Indiana University. I don't actually have the reference there, but it's Phil Menzer and colleagues at Indiana University, and it's quite a well-known, and they're very prominent researchers in this area. So it's a machine learning approach. They have an API, application programming interface. So what we did was we submitted our 1.4 million Twitter usernames to their API, and what that returns is a number ranging from 0 to 1, where if the score is 0, it's extremely unlikely that it's a bot. While if the score is 1, it's extremely likely to be a bot. So it's a continuum of botness, I guess you could say. And it's, as I mentioned, it's a machine learning approach. So what they do is they have a classifier that they've built where they've manually coded up, the training data set, they've manually coded Twitter users as being bots or not bots. And then they build a classifier which then relates all of these features that can be automatically collected, such as user base. So this is your profile, the profile data, the number of friends that they have, like who is following, or how many people they're following, how many people follow them, their centrality within the network, and also content, information about how many times they're tweeting, what types of tweets they're authoring. So that's for us, it's like a black box. We didn't try to improve upon the machine learning approach for this particular research. We just took it as it was, and we coded up our data that way. For this research, what we decided was to use a cutoff of 0.6. Other users or researchers have used a cutoff of 0.5. So if the bot score is above 0.5, then they're classified as a bot. We used a slightly higher threshold of 0.6 because we thought that we looked at it and we felt that that led to less misclassification. But I'll return to this issue of misclassification. So the second challenge was to the partisanship. How do we actually identify whether a Twitter user is a Republican supporter or a Democrat supporter? So there's two main ways that this has been done in the literature. Broadly, it's involving text data. So, for example, a set of hashtags that are deemed to be partisan in some ways, and then it's based on how many hashtags or what hashtags a person is using. So if you're only using Democrat-leaning hashtags, then you're classified as a Democrat supporter, etc. The other approach is using the network data. So this is actually looking at, for example, and this is Barbera et al. have published on this approach, where you're looking at who follows, of the users that you're wanting to classify as being Republican or Democrat, you look at who they follow on Twitter. So in particular, you look at their following behaviour or who they're following amongst a set of political actors, such as politicians, think tanks, media actors. And essentially it leads to a clustering approach. They use correspondence analysis, but there are different clustering routines that you could use. Now, in the research that I'm presenting on today, we use the text data approach. But tomorrow, in my presentation tomorrow, I'll be talking about another application where I used a network data approach to classify users on the basis of political ideology. So what we did here is we manually curated a set of, I think, around 500 hashtags that had been used during that debate, and they were manually classified as being pro Trump or pro-Clinton or pro-Republican, pro-Democrat. And so this is our word clouds showing the frequency of use of these different hashtags. And so what we did was we said that the details are in the paper, but basically if you're only using pro-Democrat hashtags, then you were deemed to be a Democrat supporter. Now, there are errors associated with such a coding approach, and this is actually being talked about in this paper by Conover et al. There is this problem of content injection or hashtag spamming. So content injection is where you're actually a Republican supporter and you put in Democrat friendly or Democrat related hashtags into your tweets in order to try and get the attention or provoke a reaction from the other side. So that does create errors of classification, and I'll just sort of say that we're aware of that. And that's actually one of the reasons why subsequent work I looked into the network approach for doing the same thing. So the third methodological challenge is how to understand the influence of a Twitter user. Now, as I've mentioned, in this approach, our definition or conceptualization of influence is your contribution to the flow or diffusion of information via retweets. So often we retweet other people's. Yes. So this is a diagram showing kind of the situation or the methodological challenge that we had here. So say we have user A tweeting, then user B comes along and retweets A's original tweet. Now, often what happens is subsequently people will retweet someone else's retweet. So that's what's happening here. Is C is retweeting user B's retweet of A. So this is a flow or a network of diffusion, really. It's because of B that C found out about A's original tweet. So this is kind of a cascade. We can think of this as a retweet cascade. We wanted this data to be able to measure influence, but the problem is that Twitter doesn't provide this data. They don't provide retweet cascade data. Instead, what they provide, and this is another diagram that shows it, the paper by Vasoi, Roy, and Al addresses exactly the same problem, is they're showing here a timeline where this person is tweeted here, and what we get from the Twitter API is all of these activities. We know that A's tweet has been retweeted at all of these different times, so this is time along here, by different people. But what's actually happened is there's been a cascade of retweeting. So this is a retweet of the original tweet. This person retweeted this person. These two people retweeted this person. So you can see this cascading as a tree. But we don't get this from the Twitter API. So people have spent time coming up with approaches for imputing or inferring the retweet cascade based on what you can get from the Twitter API. And so that's my computer science colleagues. In fact, this is something that they're doing cutting edge work in this area. And really, this paper was actually an application of a technique that they were working on. And we thought it was a good application to an area that people would have an interest in. So, and I won't go into the details of it, but they calculate influence, or the approach involves calculating influence over all of the possible realizations of retweet cascades. So all of the cascades that could have led to this pattern of, this time pattern of retweeting. This is one possible realization, but there are others. And so essentially it's a distribution of potential retweet cascades. And essentially there are weights on various potential retweet cascades based on information such as the fact that users prefer to retweet fresh content. So you're more likely to have retweeted something that you've just seen recently as opposed to something that you might have seen a long time ago. Users prefer to retweet locally central users, so this is preferential attachment. So I won't go into the mathematics of it. I would not be qualified to tell you about that, but that's what this paper did. So getting on to the actual results, what we found was that based on usage of partisan hashtags, social bots are more likely to be pro-Republican than pro-Democrat. So we found that based on this partisan hashtag approach to classifying users, the bots appeared to be more leaning towards the Republican side. When it came to the measurement of influence, what we found was that that there was a difference between the average influence of bots, depending on whether they were pro-Republican or pro-Democrat. Pro-Republican bots, or the average pro-Republican bot is twice as influential in terms of contribution to information cascades than the average pro-Democrat bot. However, and actually this is where I'll turn to this diagram. This is I think a really, for me, this is like a really nice visual. I can say this because I didn't actually create this particular visualization. I'm not patting myself on the back, but I think this is a really nice example of visualization. So what we have here is user influence along this axis. So these people down, as you move to the right, you're more influential in terms of your contribution to information cascades. On this dimension, we have botness. So, as you go up there, up the y-axis, you're more likely to be a bot. And then we have these, it's a density map, so it's showing the proportion or the number of bots or users who are occupying a particular space. And there's all sorts of funky things that are going on with the scaling, which I won't go into. But essentially what we find here is that there is a big patch of Republican, these are most likely Republican leaning, and they've got mid-influence, middling influence in terms of contribution to the information cascades. So that's there. Over here, we have a large set of people who are most likely to be humans, and they're very influential, and they're Democrat leaning. Okay, so the low bot scores and very influential. You can't see it very well, but there's a patch up there of Republican leaning bots who are very influential, and so that's kind of, I guess, an area of concern out there if you're worried about kind of the potential impact of bots on, well, especially if you're a Democrat-leaning person and you're worried about the potential impact of bots on the debate. So there are some limitations associated with this work. As always, issues associated with the accuracy of the classification of bots. As I mentioned before, well, I'll talk about this in a second. I mean, a lot of the accounts that we think are bots are actually not bots. Also, there are errors associated with classifying them on the basis of political partisanship. The other sort of limitation with this research is that influence is conceived as contribution to information diffusion, and that's quite a narrow definition of influence, really. The other thing is that someone might want to ask the question, well, overall, were the Republican bots more influential than the Democrat humans? And we can't answer that statement based on this current analysis because it's all talking about per bot or per user influence rather than aggregated influence across a set of users. So at this point, I just want to ask, what time should I be aiming to finish by? Yeah, okay, good. The second part of this presentation relates to another stream of bot-related research that I'm involved in, and this is the role and presence of bots in political conversations on Twitter. So this, as I mentioned in my introduction, this research is more, I guess it's taking a more sociological approach or political communication approach. We're not interested in this research at how bots and humans contribute to information diffusion. We're actually here interested in their participation and the role that they're taking in conversations that people are having on Twitter. So a conversation being, person A says something, person B replies, rather than just a one-to-many sort of information diffusion. So I forgot to mention in my introduction that this work is joint with Tim Graham and Florian Müller. And Florian is a sociologist at the University of Bielefeld in Germany, and we are collaborating with him via an academic exchange between Germany and Australia. So, following what we did in the ICWSM paper, we converted the bot scores into a categorical variable where if the bot score is greater than 0.6, then they're classified as a bot. If it's less than 0.2, less than 0.2 or less than or equal to 0.2, they're classified as human. And if it's somewhere in between, then they're classified as other. So using these thresholds, we found that nearly 9,000 accounts were deemed or classified as being bots. So not a huge number. Well, I guess in numerical terms, it's quite a large number, but as a proportion of the 1.4 million user accounts that were active, it's not huge. So what we did is we then we constructed a subnetwork of those actors who either sent or received at least one reply edge on so they were either replied to someone on Twitter or they were replied to by someone on Twitter. So just to clarify the types of interactions that people can have on Twitter, in network terms, we can think of really, I guess, there are, I think, 3 or 4 different types of activities that lead to different types of edges or ties within a network. If I was someone who tweeted in this network, tweeted using one of the hashtags during the debate, but my tweet didn't mention or retweet or reply to anyone else in the network, anyone else who's also in that network, then I would be what's termed an isolate in the network. I would be just a dot, not connected to anyone else. But we still have reply. The way we bring the text into the network is we conceive of there being like a loop, a self loop. So in some ways I've just retweeted or connected to myself. That's how we bring the text data in. In terms of the other types of interactions you can have, you can retweet someone. So that's essentially like you're forwarding on someone else's tweet. Or you can mention someone, and that's where your someone else's username is somewhere in the body of your tweet, but it's not at the start of your tweet. And a reply is where that person's username is right at the start of the tweet. I think with the new web interface or the new interface for Twitter, you can actually select to reply to people as well. You don't actually have to position the username at the start of the tweet. So we were only interested in interactions between people that were replies. And we restricted ourselves to replies because we felt that they were more representative or indicative of a potential conversation that might have taken place. The vast majority the majority of activities in this data set are retweets. I mean, that's what a lot of, especially during a debate, people are just retweeting what celebrities are, and media actors are tweeting. But so we got rid of all the retweets and just focused on replies. So this network contains nearly 17,000 users. So you can see by how much we've reduced the scale of the network by only focusing on replies. So we went down from 1.4 million users to nearly 17,000. And of these, 231 are classified as bots and 4,000 are classified as humans. Then what we did was we constructed the giant component. So that's the network that is the largest set of nodes that are connected to one another, either directly or indirectly. And so what we argue in the paper underlying this research is that this reply subnetwork is a snapshot of a conversation that was taking place, or a number of conversations that were taking place during this 2-hour period. Conversations relating to the debate. then what we did is we used exponential random graph modeling. So this is a statistical social network analysis technique. Essentially, and I won't make the assumption that people are using this approach, but it could be something you're already familiar with. But it's like logistic regression, but for networks. It allows you to model or understand the social forces that have led to the emergence of a particular tie or edge or tie between two actors in a network. So you can conduct statistical tests of the presence of homophily within a network, for example. So this is the idea that like connects with like, or you can. So that was the framework that we used to in this particular paper, ERGM. And now we have a number of hypotheses, but I'll just focus on one of the hypotheses that we're testing. This is that bots are more likely to reply to humans compared with humans replying to bots. So what underlies this hypothesis is our expectation is that bots were trying to target humans, trying to get them involved in conversations, and that humans were probably, they could tell that they were bots or they were not, and they would sort of shy away from them. So that's essentially what we're trying to test here. Is in some ways it's a test of, the motivation of bots. That we think that, our hypothesis was that bots were trying to get involved in conversations with humans, but also it's a test of our hypothesis that the bot technology at this time was insufficient, such that people were probably aware that it was a bot and they were not going to respond. I'm not going to go into the details of the statistical test that we conducted, but our preliminary results suggest the exact opposite. Both humans and bots appear to be directing reply edges to bots. So the bots seem to be directing attention to bots, but not only that, the humans seem to be directing attention to bots. Now, this might seem, a really, groundbreaking result. It's definitely counterintuitive, but unfortunately, it comes about because of some of the methodological and data challenges that we have in doing this type of research. Again, doing this kind of research at scale. We don't have a data set here where we went and manually looked at the Twitter users and said, yes, that's a bot, that's a human. For this particular study, we're using the bot or not API to classify actors as users as being bots or humans. So we have two major challenges with our data. This one is actually separate to the bot issue, but we have partial data here. I would like to be able to say with confidence that our reply network is a snapshot or indicative of the conversations that were taking place during the debate. But the problem is that if two people were talking about the debate and they were not using our hashtags, they weren't including one of our hashtags in their tweets, then that interaction was invisible to us. We didn't collect on it. So this is a limitation that could actually, in some particular settings, some people might say, well, that kind of invalidates the study. But at this stage, what we're doing, we're just being upfront about it, is that we appreciate that we only have partial data. But the bigger problem relating to that finding that I just showed you is that many of our so-called bots are not really bots. We are now undertaking more qualitative analysis of the data set, and that's been led by our colleague Florian in Germany. Hence, our first publication in this qualitative research is actually in a German language journal. But the English translation of the title is "Social Bots in Online Political Conversations: An Overestimated Danger for Democratic Opinion Formation on the Internet?" And what this paper is doing, what Florian did was he took a sample of the bots. So these were users that were classified as being definitely bots. And then he went and looked at them and looked at their user profile, their tweet behaviour, and I believe it was of I think 4% of the user accounts were accurately classified as being bots. So this is and many of the so-called bots are actually, as mentioned here, celebrity or institutional accounts. So what's happening here is you've got teams of people using a Twitter account in a bot-like way. They're tweeting very rapidly. They're tweeting in a sort of a mechanical, they're doing lots of retweeting. And so it's actually appearing as a bot, but in fact it's actually a team of people sort of acting in a bot-like fashion. So conceptually we're struggling with this a bit. We're not sure exactly how that's going to impact on the research. But when we were in Germany, we had this conceptual breakthrough and decided that in fact what we're dealing with is this what's known as kit figuring. So this is a social psychological sort of phenomenon of where things appear one way, in fact there's something else. So this is an example of it. It looks like a vase, or it looks like two faces. And this is another example where it's titled "My Wife and My Mother-in-Law." So if you look at it carefully, you'll see either a young woman or an old woman with a shawl. And so this is our problem: is that we have these perceptual objects that are appearing as ambiguous. I mean, we're perceiving them as bots because we're using the bottleneck API, but in fact they're not bots when we drill down further into it. So that's it for the presentation. I just wanted to emphasise some of the methodological challenges that we're having, and I'll finish up there. I'm very happy to take any questions that you may have. Thank you. Yep, off the back.
That was a very good presentation. Thank you very much for that. I do have a lot of questions on the last thing you talked about, the 4%.
Yep.
So you're saying that you had what you thought was 100% confidence in what bots were, but it turned out when you looked at them individually, only 4% turned out to actually be bots? Is that what you said?
That's right. Yeah, based on this. So the question is about this, the 4%. I mentioned that a qualitative analysis of 100 so-called bot accounts led to the conclusion that only 4 of them were actually bots. Yeah, so that's exactly right. So it's a problem with, and this is the challenge of using an automated approach. The bottleneck people, the people behind the bottleneck algorithm have done a lot of work subsequently, and I'm sure the current version has a much more accurate kind of is much more accurate. But also, I think it's a real challenge because if you're using an API, then by definition you're looking for factors that are about, for example, frequency of tweets or particular keywords that are being used, and it's there's always going to be an inaccuracy associated with that. So I think the machine learning, I'm sure, is improving, but for the version that we use, we found quite a serious misclassification. So that does call into kind of question some of the other results that we have. Yes.
In your experience, is it the responsibility of these social media companies to become better at dealing with misinformation, or our job as human actors to become more equipped to better process the information we take in, or some combination of both?
Yeah, I'm a classic fence sitter, so I'm going to take the third option. I mean, I think that I have added views about this related to. I'm going to take a slight diversion. So the question here is about is it up to the social media companies to prevent misinformation, or is it the individual, the social media user's responsibility to know when they're dealing with misinformation, or is it something in between? So I feel that it is something in between, because I think that essentially if the social media companies know that there are actors out there that are putting out misinformation and they can automatically detect it, then I think there is something to be said with dealing with it. But it actually then it gets us into quite difficult territory potentially quickly, in the sense that it can lead to, by definition, these will be automated approaches for identifying misinformation, fake news, and there is this classification error that can occur. And so, I mean, next thing you know, there'll be people getting censored, or voices being censored because somehow they triggered a misinformation sort of alert, and they've been taken off, social media. So I think it's an interesting time that we're in, because I think that 10 years ago, if there was ever talk about censorship on the internet, in fact, in Australia, there was a big debate about it because there was an internet filter that was proposed and the government was trying to get built. And there was such a big outcry about it from the social media companies, the technologists, who said, no, you can't filter the internet. It won't work. It's individuals' private responsibility to, make sure that, if they have family, that their children are not exposed to nasty stuff on the internet. And it was really being put back onto the individual's responsibility. But I think in the last 5 years, the whole debate has completely changed, and now we're actually wanting these companies to censor or to restrict misinformation, but this is going to lead to censorship as well. So I think it's a really thorny, challenging area. So I guess I just have to sit on the fence in that regard. Yes?
So I'm a firm believer that bots or robots will definitely outsmart human beings. I mean, no matter how better we get in identifying bots, they'll always be one step ahead of us. So whatever you talked about, I think these are more of the precautionary measures instead of the cure. So don't you think so that instead of identifying bots and then removing them from the platform, they should not be allowed to sign up on the platform in the first place?
Who's they? The people behind them?
I mean the people who are operating the bots.
Yeah. Well, look, I think it's true. I mean, if they can solve I think it's going to be it's going to be very difficult. I mean, if this sort of thing was easy to control, then we wouldn't be receiving all the spam email that we still receive. 20 years after the email became widespread. Inboxes are inundated with spam and phishing kind of emails, and so I agree that the problem is that there are people who are motivated to just build better bots, and the companies are going to be one step behind in that regard. So I think this gets back to the other point, is that it does require individuals to become aware about their information environment and try to assess, because I think humans are always going to be the best people to assess what we're seeing. So yeah.
I have two questions. So first, thank you for the presentation. It was great. So did you run any further analysis about the difference, whether there was significant difference between the bot-like and the bot, like when you categorized, you found that some of them that you categorized as bots, they turned out to be bot-like. Did you run any further analysis to look at whether there was significant difference between bot and bot-like?
Like between the real, in inverted commas, real bots and no, we haven't done that yet. That's part of what we're doing at the moment. Is in some ways we're still trying to get this work out, where we're saying, okay, look, this is a network with our best guesses based on the bot or on API, who the bots were, what were these bots in inverted commas doing. So, but in addition, in parallel to that, we're also doing other analysis where we're saying, okay, of the ones that we have manually classified by as bots, what do they look like? What are they doing, compared to the bot-like ones? So
yeah, because that would tell us a lot about maybe the bot and bot-like would have same behavior, though they are inherently different, but the behavior would be the same.
Well, in fact, I think in some ways that we might find that's the case, because the whole reason why they got classified altogether as bots is because they have behavior that is observable, using automated means. So what we're trying to see is whether or not, I guess it's an interesting thing, but in some ways it's us almost trying to reverse engineer the bot or not API in that regard, which is something that we don't want to be doing.
The other question is related to the number that you used. I noticed that you turned out by classifying about 4,000 out of the 16,000 in terms of whether bots or humans.
Yeah, 4,000 were humans.
And there were the in-betweens.
Yes.
You didn't decide. So how did you deal with the in-betweens? Did you run them with the ERGM model as well?
Yeah, they became like a control category in the ERGM. Yeah, they were kind of the residual kind of group. Yeah. And so what we then we left them in there, because if we took them out, we're only interested in the bots and the humans, but with a network, if we took out the others, then we just have a completely disconnected network. So they're in there, but they're like almost like ordinary, standard regression perspective, with dummy variables. They're like a control group. Yeah. Yes.
So for like using bots for spreading information in the social media is not acceptable to the public if they know about it. But seems like they are not aware about it. So it is really influencing the final outcome, like in the election process, when the bots start spreading the information. It's influencing the final outcome, right? Don't you think there should be some strict regulation to control this?
Well, I think this is the concern, is that, and I think in some ways a lot of the concern about the potential impact, the connection between social media behaviour and the election outcome, a lot of it actually centred on Facebook rather than Twitter, I would have to say, because and it's in the context of these foreign operated troll accounts that were purchasing Facebook ads that were clearly targeting particular voter demographics in a strategic way. And I think that's very different to well, I guess it's related to behaviour to what we're looking at here. But I guess my role in all of this type of research is trying to understand what I think there's a risk of moral panic about bots, and this kind of people thinking, okay, they're having an impact. But the question is, well, how do we know that they had an impact? How do we even know who the bots were, let alone what sort of impact they had? And so what we're trying to do with this research is sort of take a step back and say, okay, yes, it's reasonable to expect that there were bots that were operational, were present and involved in retweeting information during the debate. But the question is, how many of them were there, and was anyone listening to them? Or were they, and compared to the humans, in particular the Democrat-leaning humans, our findings would suggest that yes, on a per user basis, the bots were quite influential, but they were vastly outweighed by the number of very influential accounts that users who seem to be human, and that they're these celebrities who are Democrat-leaning. So I think it's a balance, and we're just trying to come up with some of the parameters.
So we have time for one more question.
Yes, ma'am.
Yeah, I have a more general question. Do you think that the day will come, and maybe because of the good, because of the content that they bring and push us, social media will become unreliable and we will die, and we will all be back to some more normal media?
I personally think the social media genie is out of the bottle. I'm someone who I feel that I don't think we'll go back to not having some form of communication, technology such as social media. But I actually think where the changes might be is in terms of what people put out about themselves online, in terms of the privacy issue. I can imagine a world where people have much more control over their data, are much more careful about who they give access to, but still they're using social media to connect and to promote, to share. So I don't think we're going to go back to a pre-social media age, but I think we may have given all the privacy concerns, maybe we'll have a situation where social media companies are public utilities and the data are being treated in a way that fits better with in terms of social outcomes. But I think in terms of the connectivity, networks were around before social media, and now they're online, and I don't think we're going to go back from that.
So on this note, thank you, Rob.
Thank you.